Hi, greetings. I'm Subhabani and welcome everyone in my new video. In this video, I will show you how to do analog layout. Basically, I will do couple of videos on analog layout. After completing analog layout tutorials, I will show everyone how to design analog circuitry very well. So before starting, I would like to say something. For practicing this tutorial at home, you should be able to access in Cadence software. You can use any version of Cadence software. You can use any technology. Professionally, I am working as a layout engineer and I have completed my master's program from Concordia University, where my major focus was microelectronics. So I hope that this video helps you students especially a lot, and you will find how basically engineers use matching techniques especially, as well as in professional tool there are various tools such as Cadence, Siemens, custom compiler of synopsis, and they have too much flexibility to for analog layout. For instance, if I tell you something about the the custom compiler has inbuilt some function that helps us to do analog layout matching very well. But however, in this video tutorial, I will show you some basic fundamental things. These basic things actually helps you guys to develop a sense that how layout going on. So let's start this video. Okay, and in this video, I will show you how to do layout for differential pair. This differential pair is very crucial. You will find this differential pair in every analog circuitry. For example, any OPAMP or there are most of the circuits you will find differential input pair. One more crucial point is that this differential input pair, the analog layout matching is very important because it's differential. In differential mean there is a common mode level, and if one goes up, which you tell positive, then the another signal is going down by the same amount. For example, it's up by 20 millivolt. This signal will go 20 millivolt down from a common mode level. So we should match this voltage very well. Otherwise, the overall performance of the system will be damaged. So however, Nori, I will show you that how a good layout matching can you make for your own differential pair. Here, for example, I will show you that for NMOS differential pair, and in this video, I just only show you how to draw circuit in Cadence as well as how to match circuit. In my next video tutorial, I will show you how to routing all of the circuitry. And in my third tutorial, although it might not possible from my computer because here I have no access in any gathering annual tap cell. So in professional life, we are using tap cell, but so on. Let's begin for now. In part 3, I will explain my limitation and I will also tell you people that how you can using the tap cell professionally, but I have no access because my version is a student version, so I have limited access. But I try to show my best that you can understand the analog layout matching very well. So let's begin and keep touching my video and subscribe my channel that whenever I will upload any new video, you can learn it very easily because in this types of video is not too much available in YouTube. I will show you some important video in real life that how you can do that. So must subscribe my channel and share with your friend, that I will be motivated to make this kind of video too much for you people or the students especially. Okay, I shared my screen and I hope that you can see my screen. And here it is the differential pair of NMOS. And I want to add one point, that whenever you start analog layout, first of all, you should know which device which is. Mean there might be some current mirror, there might be some diode connected load, or there might be one diode connected load which will be reference some of the couple of PMOS or NMOS for current. Okay, in my next video, whenever I will make on current mirror, I will show you this thing. But right now, I want to say that before going to layout, you should understand the circuitry, which circuit or which transistor should match with which one, and you should make group and so on. So you should know this is the differential pair. So whenever you see something like this in your circuitry, you should identify it is a differential pair. And in my next video, I also show you how PMOS differential pair look like. So here you should do here, if I go to the property, then you can see there I use the length and width. It may be anything, but here I used 5 micro, and I use 16 device. It's mean there is 16 unit device which width and length. There are 16 unit device which width and length each are 5 micro. So you can see 16 device like this, and same for this device. However, I am using GPDK 45nm technology. And one more thing I want to add, that some people do a mistake, and whenever they are doing differential pair, they connected the body of this NMOS to ground. But we remember, ideally, actually we try to reduce the body effect of any transistor, especially for analog devices. For example, audio signal, Bluetooth signal, or high frequency signal, there are lots of noise, so matching is very important there. So be remember to avoid any offset or any unwanted issue. We always try to keep there is no body effect. And one of the easiest way that to reduce the body effect, that the bulk of the transistor as well as the source of the transistor should be the same net. Some people connected NMOS to ground and PMOS to VDD to just for connection, but to this kind of connection can make body effect if there is cascaded device or cascaded device, or there is branch of devices, though this kind of uh, circuit may create body effect. So I don't connect this device with VSS, I connected it with PTAil, which is the source of this NMOSes. And here you can see there should be some other circuitry in the top. Whenever I will complete the circuit, for example, two-stage OPAMP, you can see that how the entire circuitry may look like. But right now, just focus on these two transistors, because you have to match these two transistors separately. The students who don't know how to draw circuit in Cadence, for them, I am just showing you that If still you have problem that how to create a library, how to create a cell view, please comment. I will make a separate video for that. Right now, I am just showing you how to uh, draw the circuit in Cadence. For this, you have to hit I. You have to hit I in your keyboard, which is a shortcut key or bind key. Then you should browse for your GPDK file here, or my technology file is GPDK45. So whenever you go to your technology file, then if you search by NMOS or PMOS, then you will find it. Or there are actually couple of devices. Basically, it depends on the design. So I don't like to go in this way right now. Just focus on the layout only. Okay, to create the layout, you should go from create. However, I am not used to in Cadence right now. Right now, I am working in a company, as I told, and that company basically we use a different software. So it might be some uncomfortable for me using Cadence because I used Cadence around 2 and 3 years ago. So I try to help you people also. Okay, from cell view, you can go from cell view, and this is the library name. This is the cell name, differential stage. This is the cell, the schematic name. From schematic, this is the schematic view. And so, no. Oh, I'm sorry. In this way, basically we can make the symbol. Okay, as I told that I totally forget how to use Cadence, but no worry. I remember from here, if you go layout Excel, then I believe you can generate. You should create open existing. No, I have to create a new and create new. Okay, but this thing only do one time. Whenever let's say you completed your layout 30% and you save it, and now you want to redraw your other portion, then you should create open existing, and you should select automatic, open existing and automatic. If you mistakenly again, whenever second time you open the Cadence, if you select create new, then it will permanently delete your previous work. So be careful. And whenever I am doing the matching, at that time I will also show you some additional information. For example, okay, talk it later. But right now, I want to start quickly. Okay, the type is layout. Okay, yes, I want to overwrite it. Okay, then now here you can see. Okay, and this is my layout window. And from this layout window, you should go connectivity, update. I am repeating, from connectivity, go to update and component and net. Select component and net. We never select IO pin, pair boundary. No, I will talk on this later. But right now, just select the instance. Instance mean the MOS devices. Okay, okay, cool. Then from your keyboard, press Shift F. Whenever you press Shift F, then you can see the complete MOSFET. If I zoom something here, you can see this is the big MOSFET. Okay, okay. Then for showing you, if I press F, let's say it zoom out. If I click anywhere in this black screen, and if I hit F, then it will be a full view for me. Same case here. If I click here, any of the backspace, and if I hit F, then I can see the full view. And if I press any MOSFET, then I can see this is the 16 transistor of this transistor, let's say A. If it is transistor A, and here you can see the 16 multiple fingers of A, 1 2 3 4 and 1 2 3 4 16. And same for these devices. Okay, so right now I don't need this one, but if you need, then you can see, or I will show you how to use this schematic and layout, how to see that, because it's very convenient to you. Whenever you're doing layout, you should follow all this the schematic also. Used to what we do, we have two big monitor. One monitor we use to open the schematic, and the second monitor for layout. Okay, in this video, I promised you guys I will show you the professional matching technique for differential pair. So let's see that. Okay, as I know, this 1, 2, 3, 4, this is my one single devices. So I'm selecting these, and if I select this and if I hit M, which is for move, I select all of the transistor, and if I press M, then I can select this. 1, 2, 3. Okay, this is also. If I uh, hit Shift, if I press Shift, and if I can select multiple transistor, and again hit M from keyboard, and I can move this transistor. Okay, this is transistor A and this is transistor B. My job is I should match these 16 transistor. Very careful. I should match this 16 transistor like a checkerboard. Or you can see that, for example, if this is a paper, if I cut this paper like this, or if I flip this paper like this, it should be marked with everyone. Okay, I'm showing you that what I want to say. Let's say, okay, one more crucial thing I want to show you, that if you hit F4 from keyboard, you can see that this is partial selection. You can see P here for partial, or if I again select F4, you can see this is full select. Okay, how about use this tool? How to use this, I will show you later. But right now, I want to match these devices. Let's say it is A devices and it is B devices. Okay, if I match like this, okay, you can see this symbol. Basically, you can change that. That if I want to move this any angle, then you can change it like this. If I change like a plus, then I can only move these devices like vertically or horizontally. Don't never I can move these devices any angle. So I want to play with this transistor, then I want to move this transistor very quickly. So right now I am making this mode for any angle, so I can move this transistor anywhere what I need. However, one more settings, if I hit E from keyboard, then I will find that X snapping and Y snapping. It's mean the how my cursor is moving. Okay, and you should set it 0.005 0.005. You should not change it. It's the by default. If you change it in future, you will find some DRCs. It's basically technology and DRC related issue. Right now, I'm just showing you. Don't change anything from here. And whenever you need to change anything, in my previous video, I will show how you should play with this tool. Right now, it's a very beginner. Okay, be remember, it's my A, and let's say it's my V. Okay, then the matching is A, B, B, A, B, B, A, okay, mhm. And then again A, B, sorry, B, A. Right now, I'm zooming using the middle button of your mouse, or you can use the right button of your mouse. You can select area, then it will zoom for you. So here, basically, I am making the devices close. And whenever I am connecting these devices, there are lots of stuff I should do. I should align these devices very well. For right now, for quick, that my screen is small, so therefore I'm just quickly keep placing these devices near of them that I can easily. Okay, you may ask if it is common centroid, it is interdigitized. Most of the students basically they confused when someone tells them common centroid interdigitized. So I never tell you any name. I just show you how to do that. Whatever the name, forget the name. I show you the easiest way, then how the matching should do. How what is the proper way of matching? I'll show that. And if I believe if you enjoy my next video tutorials also, you will learn that. You can learn it naturally. Okay. Right now the matching is A B B A A B B A. Okay. If I show you the schematic, then you can see the A devices. A, B, B, A, B, B, A. Okay. So the next matching should be, this is my A, right? You should just place B downside of A, just opposite. This was A, it is B. This two is V. So now here I put two A devices. Then it is A, so I am putting a B devices. Then again it is A, so I am putting a V devices. Then these two are B, then I am putting A. Okay, then one more V devices here. Okay, I can check it. Okay, A, and this two is my V, so there two is A, this two is B, so this two is A, this two is B, so this two is A, this is V, so this is my A, so it is my A, so it is my V. Okay, now I am keeping these devices closely. This video is only for that how to match differential pair. I don't want to teach you anything else. In my next video, I will show you something. For example, there are also an align tool that I can align them. For instance, I don't want to move this device manually. I want to align this with this device. How can I do that? I select this device. I should hit A from keyboard. Then, okay, one more point. If I click here, in here, if I click used, then I can only see the used material. Sorry, the used metal layer. Okay, in my next video I will show you how MOSFET from, or how can we basically, how can we make our own MOSFET from custom, mean adding one by one layer. Okay, there are lots of stuff I will show. Please enjoy my video. So okay, right now I'm showing you how to align this. I am selecting this. I hit A from my keyboard, and if I select this upper layer, I am selecting poly. So the poly layer, and I want to up this poly like this. So I am selecting this layer. So you can see this poly is here. So now I want to align this device with that. So what should I do? I should select this device, hit A, and then I am selecting this line should be aligned to this. Then you can see I don't need to move anything. And in this way, let's say if I aligning all of the devices, it looks cool. Let's say move it. Okay, for aligning, you should keep it like a plus. Then you can move it orthogonal and diagonal. Don't move corner to corner anything, because if I do that, it will be very hard to align that all of the stuff. Okay, so right now I am just keeping it a little bit up. I just move it by pressing M. I select it. I hit A from keyboard, and I want to select this layer. Okay, now it is aligned. So right now I am selecting all of the devices. Okay, and I hit A from keyboard for align, and I want to make this height equal. Now you can see all of the devices in the same height, but this X distance is not same. Okay, this is good for now. Okay. Okay, then what should be the next step? Okay, it's the very interesting thing. The next step is that just copy this step. I forget. Sorry. Okay, this was my A devices, right? So, okay, just for a quick. B, A, A, B, B, A, A, B. Once I complete it, then you can see that what I would like to tell you guys. Okay. I want my laptop screen is too much small, so I'm working in a big screen as well as with a different software. So, but when I was a student, I used this Cadence software very well. Therefore, still, I remember how to use Cadence. So, I also suggest you guys, whenever you are getting free time, try to practice this software, because this software is basically using in professional life. So, whenever you are familiar with this software, it will be helpful for you to get a job especially, and in the job life also you will not face too much difficulty, because uh, yeah, I am facing issue because in my office uh, there are different buying key for align or everything, or it's a different issue. So here, yeah, definitely I am facing some inconvenience, but my target is to show you that how to match differential pair. And if I place the devices almost correct, if I place, then you can see the beauty of the matching, right? If I did not place devices correctly, then you cannot understand the beauty of this matching. So I tried to keep this, but whatever I'm doing is not the professional way to do that. We are using align tool, or there are some special tool which basically make our tasks some comfortable or some automation there. Okay, right now I do quickly. You see how this device look like, and you definitely know that this mean this match should be comes in the bottom, and it is my A devices, and the matching should be A V V A A V V A. Now if I hit F, then you can see the full screen. So now if I just quick align all of the devices for you, then it may looks cool. Okay. I'm selecting all of the devices. I want to match this height. Same for all of them. Okay, it's good for now. I think that you understand that how should do the matching of a diff pair, and I believe that if the number of figure or number of finger or multiplier if change, it surely change depending on the design, but I believe that you can do the matching, and I'm showing you that what basically what we want from a layout engineer, the what should the matching looks like. You can see like uh, it's this stage, and the second stage, and the second stage and third stage is looks like same, and the first stage is the repeating in the bottom. And if you think that if you just fold these two things like this, it will be merged with one another. You understand what I would like to say? I believe you can see that. And if I press here, then you also can see that it is a checkerboard like matching. It's match like B divides here, B here, B here, B like this. Okay, you can see this matching, and you should always do differential matching like this. And in my second video, I will show you how to add dummy there. After adding dummy, yeah, after adding dummy, I will route this. So there might be couple of videos. If I show everything in one videos, it will not be good for you. So I am making a couple of stage of video for this one, and this basically helps you a lot to learn the basic analog layout. For example, it supports the students specially. Okay, bye for now. So I think that you understand the how differential pair looks like. You can see. Okay, but if I will also show you some professional matching. For example, there are some critical circuitry where the multiplier may be 100. Then how you do that? And it is 16, but I will also show you that. No worry. Keep in touch. Bye for now and practice it a lot. Have a good day.